Hey guys, Mr. Backberg here. In this video, we're going to look at the law of exponential change. Now, you've probably done enough with exponential growth problems to recognize they involve growth in which the rate of change is proportional to the amount present. So the more bacteria you have in a dish, the faster they're going to multiply. The more radioactive material you have, the faster it's going to decay. The more money you have in your bank account, the faster it's going to grow. Well, we can write out a differential equation to represent this type of growth. So we can write it out as dy dt equals k times y, where k is the exponential growth constant if it's positive, or the exponential decay constant if that k value is negative. But we can actually do some manipulation with this differential equation to make it look more like our exponential problems that we're used to dealing with. So if we take that dy dt equals k times y, what we're going to do is manipulate it using what we know about differential equations. So I'm going to divide this y over to the other side, and I'm going to multiply this dt over to the right-hand side. So then this will say 1 over y dy is equal to k dt. And then what we're going to do is go ahead and integrate both sides with respect to each variable. So on the left-hand side, we're integrating with respect to y. So when we do the integral of 1 over y, that turns into a natural log. So it's the natural log of the absolute value of y. Now on the right-hand side, when we do that integration, k is really just a constant. So what we're going to need to do with that is attach a t variable to that. But then because we're doing an indefinite integral, we have to put our plus c. And I'm going to put it on the right-hand side. Now what we're going to do is try to get y all by itself. Having that natural log in front, to cancel out a natural log, we want to do something called exponentiating both sides. So what we're going to do is take e and raise it to what we have on each side. So on the left-hand side, we're going to have e raised to the ln of the absolute value of y. And on the right-hand side, we're going to take e and raise it to the kt plus c power. Now, the reason why we do that is because on the left-hand side, the e and the natural log are going to cancel each other out. So then we get just the absolute value of y is equal to e to the power kt plus c. But then we can use a property of exponents to rewrite that right-hand side. When you've got addition happening with exponents, that came from having multiplication with the exact same base. So we could actually rewrite this as e to the c times e to the kt, because if you multiply the same base together, then you add the exponents. Now with that absolute value on the left-hand side, we know that absolute value takes whatever's inside of it and turns it positive. So if we know that this right-hand side is equal to the absolute value of y, then we can rewrite this as either plus or minus this stuff on the right-hand side, because if we were to do its absolute value, then it would just turn into that regular y. But then what we're going to do is a little bit of substitution. And what we're going to do is let a equal this plus or minus e to the c. So then what this is going to say will be y equals a times e to the kt. And that looks more like exponential growth types of problems or exponential decay problems that you're used to working with. Now, one thing to note, that a value is the amount present when t is equal to 0. So sometimes you might see this a written as y sub 0. So it could say y sub 0 times e to the kt. Just recognize those are the exact same equation. That a value just stands for your initial y value amount. So really what we've just gone through and talked about was the law of exponential change. So if y changes at a rate proportional to the amount present, so if we've got that dy dt equals k times y, and if we know that y is equal to y sub 0 when t is equal to 0, then we can write out the equation y equals y sub 0 times e to the kt. And again, that constant k is the exponential growth constant if it's positive, or we call it the exponential decay constant if it's negative. That's going to be it for this video. Thanks for watching.